All right, so we have a, an image right here that we need to look at real quick. But I want you to be aware that the next time we meet, we're going to have a quiz. And the deadline is December 12th for any late work. So let's look at this image. So this is a thermal imaging camera, and it's of a hitter, a baseball game, and you can see the pitcher has thrown a ball, and when it hits the bat right there, do you see the heat that was given off by the friction? Okay, notice also that the ball hits the man's ankle and it's transferred to the ankle. Do you see that right down there in the lower end corner of the frame? Okay, pretty cool, right? All right, so you've already written your statement on the first page of your packet. We as student engineers seek to create an app and small-scale version in order to make a safe, exciting bungee jump attraction for Oaks Amusement Park. Note that we have this schematic here. We have Iggy. His mass is 150 grams. Wild guess is how much string should we use. It's going to be in meters, so we don't know how the length of the string is. The bungee length is 0.6 meters, but we don't know how much it stretches. Iggy's height is 0.3 of a meter, and the buffer zone is 0.4 of a meter. Okay, so you know this is the purple is the bungee, and when Iggy is thrown off the balcony, the bungee is taut at this point, and then it stretches, and then it's continuing to stretch until Iggy has reached the buffer zone. These are your vocabulary words and your definitions. I would suggest writing in the example. You can come back to these and you could do them on your own. The PhET simulation. We did the PhET simulation the other day, and we have our energy bar charts. You are very familiar with those. Okay. And then you're just going to take turns with your partner, or maybe you can just take a look. It's like, what do you notice about the bar charts? That they always equal the total. They are going up and down depending on where the skater is. Okay, so when you're up at positions 1 and 5, it is all potential. See right there? And then we reach 2 and 4. It is half of its kinetic, half of its potential. And then we're down here at position 3. Watch this. It's all kinetic. Okay. There's no gravitational potential because the skater is not above ground. All right. So here you can see this is what it looks like. All gravitational, half and half, all kinetic, half and half, all potential. So these are the same. These are the same. Okay, this is the only one that's different. All right, and this one, you added friction. You can see that position 5 is not up here anymore. It's pretty much right there. Okay, and when you add thermal, you kind of slow down the skater a little bit. Okay, so you have these to do. Okay, and we did those the other day. All right, so this is the law of conservation of energy. So this is what it says. Energy can neither be created nor destroyed. It only transfers or transforms. Okay, so this is the law of conservation of energy right here. So we have the gravitational, kinetic, and elastic. Okay, these are all going to be the same. They total this number over here, and the total after is this. So after the energy has changed multiple times from gravitational to kinetic to elastic, our total is the same before as it is after. Okay, so there's no energy has been created nor has it been destroyed. So we're going to watch a couple of videos. You're going to take out 4 colors. Doesn't matter if they are these colors or not. I think this is page 3 or 4 in your packet. You're going to watch videos, and then you're going to color in these energy bar charts. So let's look. Okay, so you're gonna watch. This is a cool one. This is really cool. So you're gonna watch this. Oh, here we go. I parallel park this way. No, I don't. In my dreams, I park this way. Okay. So you need to figure out what forms of energy are present in the before situation while the car is moving, and then after the situation after the car stopped. So you're going to take your colors and you're going to give it your best guess. Stop the video and put your colors in, okay? I'm going to continue. So these are the answers. So while the car is moving, it's all kinetic. The total system is 8. Note that this system is 8, and the system that we use with the skateboard was only 6. Okay, so when we come after, we have thermal is because heat was created when the car was skidding into its parking spot, and the road was half. So that was 4 on each, and they both equal 8. All right, so you're going to watch this video, and then you're going to answer the questions. So you're going to watch the video, and then you're going to fill out an energy bar chart, just like we did with the last one. Watch the video, and then fill out your energy bar charts. But I'm going to continue. You can stop the video and do that. I'm going to go on and continue. So this is the reverse bungee jump. This is the energy transformation that happened. So the person was above ground, so he had potential. And then that elastic band was loaded with energy when it was stretched. So the system was total 8. So we have 1 for gravitational potential, and then 7 for elastic. The person way up there, bungee jumper stopped at the highest point, so the person had gravitational potential. The elastic was spent. It was whipped in the air, so that was total 8. Okay. You're going to watch this video, and you're going to figure out what kind of energy was present before, which is Tony Hawk is on the ramp, and then when it's at the bottom of the ramp. Okay, so this is your energy bar chart, and I'm going to go ahead with the answers. You can stop here, fill it out, and continue when you're ready. So a skateboarder speeds up the hill, and so the person at the top had gravitational potential, total of 8 credits, or 8 units, and then 8 units total system. When the person was halfway down, it had about 4 potential, and then we had some kinetic and a little bit of thermal, and all that up, add all that up equals 8. When the person was at the bottom, they had kinetic and they had some thermal. Okay. Continuing with their last one, we have a person jumping into I think it's a mat. And so watch the video, and then fill out your energy bar charts. You can stop it here, but I'm going to continue with the answers on the next slide. So at the beginning, the person had potential energy because it's way up top, and the total system should have been 8. When the person was moving, it had kinetic because it was moving, and potential because it's still above ground. 4 and 4, total system was 8. Now the trampoline, when the trampoline was compressed by that body when it hit the trampoline, it was filled up with so much energy, okay, that the person stopped moving, so the person doesn't have any gravitational potential energy because basically the trampoline was the floor, and it's not moving because it is stopped on the trampoline, and the trampoline was loaded with all that energy. So total system 8, trampoline was 8. Okay. Let's see. This was person. Okay. For here, I just want you to be sure that you understand what did you learn about energy today, what forms of energy stored when the bungee jumper is standing on the platform. So all this was talked about in the slides previous. Okay, and make sure you get down your vocabulary today.